So yeah, now we are going to have a look at how you can rely on communication capabilities in custom engine agents. And when I talk about communication capabilities, I mean, for example, relying on Microsoft Graph to send an email with a report or stuff like that. So this is a demo which is part of a series of labs that we have in the Copilot Dev Camp in the custom engine agent section. And specifically, this is the lab number 5 about using communication capabilities. And we will come back later on this topic when I will switch to the demo environment. So now, when it comes to building custom engine agents with Pro Code and with Visual Studio Code and .NET in this specific scenario, you can rely on Microsoft Graph simply by configuring your agent to being able to work with Microsoft Graph and to get an access token on behalf of the currently connected user. So one main thing that you need to do whenever you create such a custom engine agent is to configure the behind the scenes of your agent to have the on behalf of the OBO token retrieval enabled. And you can rely on the Microsoft Graph Client SDK or your low-level HTTP client code to consume the Microsoft Graph endpoint and to send an email or to send a Teams message or, generally speaking, communicate with other users relying on Microsoft Graph. So when you do so, the first and initial part is the configuration of the open authorization for your agent. And behind the scenes of a custom engine agent that relies on the Microsoft 365 Agent SDK and on the agent framework is to register a bot in Azure. So you need to register a new bot, and it will actually be done for you by the Agents Toolkit when you will create a new custom engine agent using the Microsoft 365 Agents Toolkit extension for Visual Studio or Visual Studio Code. You will need to provide the settings of an application registered in Entra ID, so a client ID and a secret that will be used to retrieve the OBO token for the user who is consuming your agent. You will need to provide a token exchange URL, which will be the unique URI of your application, and the scopes you want to rely on in order to get the OBO token for. And we will go to the demo environment shortly, and you will see that in practice. Once you are done with that, you can retrieve the on behalf of token inside your business logic in the custom engine agent. Clearly, this demo is a Pro Code oriented one, so we are talking about .NET code and the actual implementation of an agent using C# and .NET. And in the token retrieval logic, you can rely on a specific method which will be able to exchange a token, an OBO token, which will be exchanged providing the actual context, third context and third token of the user interacting with your agent, and you will get back from this method the OBO token that you can use to then consume the Microsoft Graph. So this will rely also in the demo that we're going to see on the agent framework, which was, by the way, released in general availability last month in April 2026. And with the Microsoft Agent Framework, we are using a set of plugins that we created in the sample that I'm going to show you. And we have a plugin which is specifically responsible of sending an email on behalf of the user using the custom engine agent with a report content that we want to use to get specific information about the agent itself. The communication plugin is nothing more than a .NET type, or generally speaking, a class that we use to provide the actual implementation of the communication inner logic, and we register that plugin inside the agent framework pipeline so that whenever the agent will need to rely on the communication capabilities through this registered plugin, it will be possible to do so. So let me switch to the demo environment. Let me show you, practically speaking, what you need to do. So first of all, as I was telling you before, this is a lab which is part of the Copilot Developer Camp, and it's available in the Custom Engine Agent section. And specifically, this is the lab BAF5, Add Communication Capabilities. Here you can go through all of the steps and do the same that I'm going to show you so that you can create the same scenario on your own environment, if you like. From a functional perspective, let me first of all show you the agent in action, and then I will explain you how it works behind the scenes. So this is my agent. It is an hypothetical agent in the fields of insurance of an hypothetical Java insurance company. And this agent helps users to work with the handling, day-to-day handling of claims made by customers. So, for example, as you can see here, you can do stuff like, let me go back to the previous one. You can do stuff like getting a specific claim. You can get information of a claim. You can get pictures filed by the customer while filing their claims. And you can also create a report about specific claim, and you can send that report through an email message to a specific user. Now, for example, let me grab a couple of prompts that I want to use, and I can use this one to retrieve the information about a specific claim that I have in the system. So this will use my custom engine agent to get information from a knowledge base, which is stored on Azure, specifically in a table storage with some information and some binary content like the images of the car crash in this specific claim. So we can get information about a specific claim. We can analyze the photo of the claim. We can check if the claim is a fraud. Today, our focus is on the communication capability, but we can still rely on this option to analyze the photo, for example, and see if the claim is a good one and what is the estimated amount to fix the car which was damaged during the car crash and stuff like that. And as you can see, the custom engine agent is doing the analysis, relying on multiple models and relying on the Mistral model to do the car crash analysis and stuff like that. But now let's say that I'm interested in generating an investigation report for this specific claim. So I can say generate the investigation report. I can provide the claim ID or not. Actually, it is already implied in the context where I am. And now the agent is working on this specific claim, and it is going to create a report with additional information that can be useful for me to have a better understanding of what's going on in this specific claim. But let's say that, for example, I want to send this report by email, and if I will simply say send the report by email, it will automatically send a nice looking email in HTML to the email account that I have for my current user, or I can ask the engine to send it to a specific target user. Okay, now the email has been sent. And if I switch to my mailbox, we can see that the email should be there, and here it is. And I have this nice looking, or supposed to be nice looking email in HTML, where I see all of the information of my claim, and I can get all of the details that I'm looking for. So that's the idea of the demo. How does it work under the cover? So first of all, let me go back to the agent itself, and let me start showing you the actual implementation. The agent is a .NET class in this scenario. You are not forced to use .NET only. You can also use Node.js and TypeScript or Python if you want, but I'm a lover of .NET, so I created this demo using .NET and C#. This is a class which represents my agent and which does inherit from the agent application. There is a set of instructions for my agent, which are the basic behavior that I'm giving to my agent. And inside the constructor of my agent, I have the initialization of an HTTP client that I'm going to use to make the actual low-level communication with the Microsoft Graph. In the settings of my agent, when I start the process with the program.cs for my service running and hosting the agent itself, I also register the HTTP client's basic settings so that whenever I will say, give me an instance of the HTTP client, I will get these settings. Then, whenever I need to consume Microsoft Graph and do communication using an email or using Teams or stuff like that, I need to retrieve the actual security context of the user and to do the retrieval of the OBO token that I was telling you before. So here, what I need to do is to rely on the user authorization context and use the exchange turn token async method I was telling you about before. Providing the turn context at the current request, I will need to provide a specific configuration, which I will show you shortly in the settings of my agent. And I will need to say that I want to get a OBO token, a token for this specific default scopes for Microsoft Graph, which means that I will get back, as the response of this method invocation, I will get back the OBO token for Microsoft Graph for my currently connected user. And that's why, if you paid attention during my demo, the agent was also writing in the streaming, working for you, and there was my name, because the agent was actually able to retrieve who the user is and to do the actions on behalf of the user. So it is happening because in the settings of my agent, if I show you, in the app settings, when it comes to the agent application, I have a set of handlers configured, and specifically I have just one, which is the default one for me, with me name for my user. And in the settings, I have a bunch of configuration parameters which tell to the M365 Agent SDK how to handle the authentication part and the retrieval of the tokens. And these settings are actually matching what I have in Azure for my bot, backing the custom engine agent. And in fact, here you can see that this bot is configured to have a specific application with this specific client ID, which is registered in Entra ID. This is the same application ID. And in the API permissions for this application, I configured that I want to have access to the email address of the user, and I want to being able to do the mail.send. So I want to have the mail.send permission scope. There are actually more than that in this list of permission scope, because in the demo I'm showing you we do more than just sending an email, but for the sake of targeting our goal, having the mail.send permission scope plus the basic permission scope like email, offline access, OpenID, and profile are enough. And actually user.read to get the information about the user. Now, in this application, we also expose an API. And the API that we expose does have a specific and dedicated scope, which is the access underscore as underscore user, which is a scope that we provide with this specific application unique URI, which is basically the bot ID prefix followed by the client ID of my application, as you can see right here. And as such, when we go back in the bot configuration, here in the lower part of the screen, we have a open authorization connection setting already defined that I created and that you will create if you will go through all of the steps of the lab. And in here, by selecting this item, we can see that I have the same client ID, the client secret that is matching the application that I showed you before. As the token exchange URL, we have the unique URI that I showed you before for my application, the tenant ID of the tenant that I'm targeting, and in the scope section, I'm targeting the access as user permission scope that I'm using to expose an API with my application. So all of these settings that I have on the Azure side are backed by the actual configuration settings that I have in my application, which is the one hosting my agent. And of course, I also have a token validation section for that specific application, so that whenever a user will provide a token, we will be able to validate if the token is targeting this specific application. So back on track on the code base of the solution, and let's move on. We can now have a look at how we register and use the communication plugin. The communication plugin is created in my code base inside the get client agent method, which is the one where we build the agent that we use to provide the response to the user. And we simply create a new instance of the communication plugin type, providing the context of the current request, the turn state, the knowledge base which we use to build the content of the email we send, and the HTTP client that we created in the constructor and that we use in order to send the email through Microsoft Graph. So if we open the communication plugin, we can see that in the communication plugin, which is just a very basic class in .NET, nothing special here. In the constructor, we get all of the input arguments of the constructor we provided in the previous code excerpt, and then we have the send claim details by email, which means that we have a method where we, first of all, retrieve the access token of the user so that we can get access to the OBO token and we can send the email on behalf of the user. And then here we rely on the LLM backing our solution, which is right now GPT-4.1, if I'm not mistaken. And here we simply create a set of specific instructions for the large language model. And we say that we want to prepare a professional claim summary for email, including, and we provide a list of information that we want to retrieve. And then we ask to the knowledge-based service we have as an internal implementation of this agent to retrieve the information we are looking for the specific claim selected by the user in the current context. Once we are done with that, we can simply create the email content. So we can go to the section where we create the email content, we provide the claim ID, and we provide all of the data that the LLM was able to retrieve from our knowledge base to build the actual message, and we get back the actual HTML well-formatted content of the email. So that we can then create a Microsoft Graph email message payload, and we can send it over the wire, targeting the Microsoft Graph endpoint for sending an email. So here we do the /v1.0/me/send mail, and we provide in the body of the request the actual JSON of the email message that we want to send. And here we are with this send method. Okay. Now, when we want to do so, we also need to register, as I was telling you, using the agent framework, the communication plugin. So once we have created an instance of the communication plugin, we then need to add it to the list of tools for our agent. And here specifically, we register the capability, the action to send an email and to generate the report. And we refer to those capabilities in the instructions of my agent simply by saying, as a text, a free text, open text for my agent in the instruction that, for example, for sending investigation reports and claim details by email, use, and we provide through curly brackets a reference to the specific method we want to use to generate the report, and then to the specific method of the plugin to send the actual email. So with this specific syntax, we are basically referring to the methods made available by the plugin that we registered before. So we configure the agent to have the authentication in place. We retrieve the OBO token. We use the OBO token with Microsoft Graph. We create the plugin and we register it. And we register also the actions, the methods provided by the plugin. And then we refer in the instructions to those methods to make it possible for the agent to do the actual outcome that we are looking for. So let me briefly switch back again to the output right here. And as such, we are able to get the actual functionality in place. So let me briefly go back to my slide deck before closing up and giving the control back to Vesa. A few links, useful links for you. This is the lab I was talking about, so you can find it at aka.ms/copilot.devcamp/BAF05. If you want to dig into the agent framework and to the logic of using plugins for custom engine agents, go to AKMS/agent framework. And if you want to dig into all of the other capabilities you have to extend Microsoft 365 Copilot with a developer mindset, go to aka.ms/copilot.devcamp. I think that's all for me, so thank you, and back to you, Vesa.